section we will learn about network topologies, TCP, Ethernet, and routing. First, we will learn out net topology, first, star topology, second, bus topology, and third, mesh topology. Let's discuss in detail. Star network topology, where all devices in the network are connected to a central device, called a hub or switch. The hub or switch acts as a central point of connection and communication between all the devices on the network. One of the advantages of a star network topology is its simplicity and ease of installation. It is also easy to manage and maintain, since each device can be easily added or removed without affecting the rest of the network. However, the use of a central hub or switch also presents a potential point of failure for the entire network. If the hub or switch fails, the entire network will be disrupted until the problem is resolved. Next, bus network topology, in which all devices on the network are connected to a single cable called a backbone or trunk. Each device on the network is connected to the backbone through a drop line or tap, which allows it to send and receive data. In a bus network topology, data is transmitted in both directions on the backbone, and all devices on the network receive the data at the same time. One of the advantages of a bus network topology is its simplicity and low cost of installation. Since only one cable is required to connect all devices, it is also easy to add or remove devices from the network without disrupting the rest of the network. However, bus networks have some limitations. The use of a single backbone means that the entire network will be disrupted if the backbone cable fails. Additionally, bus networks are not scalable and can become congested as more devices are added to the network, leading to slower data transfer rates. Moreover, bus networks are not secure. Next, mesh topology, where each device on the network is connected to every other device on the network, forming a fully interconnected network. Unlike other network topologies like bus or star, where devices are connected in a specific pattern, a mesh topology allows for multiple paths between devices. In a mesh network, each device acts as a node that can transmit and receive data. Because each device is connected to every other device, data can be transmitted in multiple directions and can take different routes to reach its destination. This makes a mesh topology highly reliable and scalable, as there are multiple paths for data to travel, and the network can continue to function even if one or more devices fail. Mesh networks can be implemented in two ways: full mesh and partial mesh. In a full mesh network, device is connected to every other device, whereas in a partial mesh network, some devices are only connected to a subset of the network. Partial mesh networks can reduce the number of connections required, making them more cost-effective, but can also reduce the network's redundancy and fault tolerance. Mesh networks are commonly used in large-scale networks, like metropolitan area networks, MANs, and wide area networks, WANs, where reliability and scalability are essential. They are also used in wireless networks, where devices can act as nodes and connect to other devices in a mesh configuration, creating a wireless mesh network. One of the disadvantages of a mesh network topology is that it requires a significant amount of cabling or wireless infrastructure, which can make it expensive to implement. Additionally, because each device is connected to multiple other devices, the network's complexity can make it difficult to manage and troubleshoot.